Hi, this is the first in a series of videos on binomial distributions. And first, let's talk about the type of problems that we will cover with binomial distributions. So here's an example. Let's say you were going to have a shipment of 800 iPods. And there was a 1% chance for each iPod of being defective. And you had the question, if you ship 800 iPods, what's the probability of exactly 4 defective iPods in a shipment of 800? And that's exactly the type of problem. If you notice, there's a certain set number of iPods. Each one has an equal chance of being defective, and you win the probability of that certain number of being defective. So first, in this video, let's describe what we call the binomial situation. And the binomial situation is when you have several independent trials with the following conditions. The conditions need that it's a binary trial, that it's independent, that the number of trials is fixed, and that you have a certain number of successes. So let's go in each one of these individually. So what do we mean by binary? What we mean by binary is that each trial can be defined as either a success or a failure, or a yes or a no if you wish. An example would be obviously flipping a coin, because a coin is either heads or tails, so that's a binary choice. Though another example would be roll a die, where we define a success is to roll a 6. Another example is if you have a light bulb and you want to know if it works or not, or if it's defective. If you notice, all of these are binary because you flip a coin, you either get a head or a tail. You roll a die, you either get a 6 or you don't get a 6. And if you have a light bulb, it is either defective or it's not defective. So each trial needs to be binary. The second requirement is that each trial is independent. That is, the probability of success is unaffected by previous attempts. An example is that if you roll a die and you're trying to count the number of 6s, then whether you get a 6 on one roll is independent of whether you get a 6 on another roll. Another key is that the probability is constant. So for example, when you roll a die, the probability of getting a 6 is the same for each individual roll. The next one is key point to remember is the number, and that is the number of trials is fixed. And it's set before you start. And the last key is success. What we mean by that is that each trial can be determined or can be defined as either a success or a failure. And these are just terms that we use. We don't mean good or bad here. And the key is that the probability of success is constant. So that's the binomial situation. And here's some example of binary situations. You roll a die 6 times, and you want to find the probability that you get exactly 2 5s. So in that case, success would be getting a 5 when you roll a die. You roll it 6 times, and the question is, do you get 2 successes in those 6 rolls? Here's another example. You flip a coin 12 times, and the question is, what's the probability of getting exactly 5 heads? Another example is that if a person has 6 children, what's the probability that they have exactly 4 boys? And if you notice, all of these examples fit exactly the circumstances that we discussed before. And that describes the binomial situation. And then in the next video we'll talk about binomial probability.